So what we're doing is solving logarithmic equations. This particular logarithmic equation has a log that has an unwritten base in it. That means it's a common logarithm. That's what you call it when it doesn't have a base, but its base is really a 10. It's just not written. So the first thing we can do is write the 10 in here, even though it won't be written in our original problem. Now what we need to do is somehow isolate this x. So the way we're going to go about this problem is we're going to change this problem into a logarithm, or into a exponential. So we can do that by starting at the 10, moving to the other side to the 0.5, and coming back to the inside of the logarithm, the argument. That will give us the exponential equation. 10 to the 0.5 is equal to 10 minus 2x. 10 to the 0.5 is actually the square root of 10. Anything raised to the 0.5 is actually a square root. So we get square root of 10 equals 10 minus 2x. I'm going to isolate the variable here, so I need to subtract 10 from both sides. I'm not going to subtract the square root of 10 minus 10 and get 0. The square root of 10 must remain separate from the subtracting 10 here. So what I'm actually going to get is negative 10 plus the square root of 10 equals negative 2x. I'm going to next divide by the negative 2. So what I'm going to get is x equals negative 10 plus the square root of 10 over 2, negative 2. That can also be written as 10 minus the square root of 10 over positive 2. I simply distribute the negative to the top, and that's probably the best way to write it. But one more way you could possibly write this is x equals, if you do 10 divided by 2, you get 5, and you could write this other one as 1/2 square root of 10. That's another way of writing it, but like I said, this way in the middle here is probably the best way to write it. You could also write that answer as a decimal, and that's your solution.